Welcome to my today's presentation. It is about to master calculus 1, that is implicit function. I have 4 examples to show you, and I'm sure you are going to adapt with it very well. The first example is x squared plus y squared is equals to 3. I hope you still remember that differentiation. You can differentiate with respect to x or with respect to y. For our case here, we are trying to differentiate with respect to x. Let me remind you about the power rule. That is, you differentiate if you are given a function y is equals to x raised to n. dy dx becomes n and raised to x raised to n minus 1. For our case here, that is the equation was x squared minus 3. So you get 2x raised to 2 minus 1 plus 2 uh, raised to 2y raised to 2 minus 1 dy dx. Because you are differentiating with respect to x, you write dy dx is equals to 0, because a differentiation of a constant is a constant itself. Thus we get, when we collect the like terms, 2 dy dx is equals to negative 2x, because you have this figure across the equal sign. And the answer we get, dy dx is equals to negative 2x over 2y, because we say over 2y over 2y. Let me give you the next example. Example number 2. You have been told, find the gradient in the curve of the curve in the equation x squared 2 plus 2xy minus 2y squared plus x is equals to 2 at point negative 4 negative 4y. We have the solution. We are differentiating with respect to x. You can choose to differentiate with respect to y, but remember you have to follow all the steps. So we are differentiating this figure. X squared becomes 2x 2 minus 1. Next figure is this one. I want you to begin on this 2xy. If you still remember the product rule, there is, we used to say u per phi minus plus phi per u. That is the product rule. You differentiate the first function, you multiply by the original, and you differentiate the second, multiply by the original. Let's see. U per in that case is 2x, so u is 2x, u per becomes 2. Phi is y, phi per is 1 dy dx, because it is a constant. So you say u per phi, so u per phi becomes 2y, and phi per u, which is phi per, which is dy dx, times 2x. And let's go to this minus 2y squared. When you differentiate, you say 2 times 2, which is 4 y raised to 2 minus 1. You get 4y dy dx, because we are differentiating with respect to x, and plus x. So you say 1x, you carry x raised to 1 minus 1, which is a constant, becomes 1, and is equals to 2. So differentiation of a constant is a constant itself, so it becomes 0. And this is simplify. You get 2x plus 2y plus 2x dy dx minus 4y dy dx plus 1 is equals to 0. You have to collect the like terms to make it simpler. So I prefer the dy dx to be on the left side and the constant figures to be on the right hand side. And 2x dy dx minus 4y dy dx is equals to negative 2x minus 2y minus 1. Remember, when a positive sign crosses an equal sign, becomes negative, and vice versa. So let's get dx becomes negative 2x minus 2y minus 1 over 2x minus 4y. That is good. Because we were told to find the gradient, you just replace. Remember, dy dx is similar to the same as gradient. So negative 2, which was the initial, you replace where x and y values with this equation here. And dy dx is equals to negative 2 into negative 4 minus 2 times 1 all over 2 times negative 4 minus 4 times 1. You get 5 over 12. 5 over 12 is our gradient, and that is our example number 2. Let's go to example number 3. The question asks, find dy dx where x squared plus 2xy plus y squared is equals to 3. You can try this. I know you are now conversant with it. So the solution is, you differentiate first, that is, you get 2x raised to 2 minus 1, and the next one is this one. Use the product rule, that is u per phi plus phi per u. So u per becomes 2, which is 2 times phi, which is 2y, and phi per u, phi per is 1, and u and phi is 2x, so becomes 2x dy dx. Remember, it's dy dx because we are differentiating with respect to x. So plus this one now, y squared, which is, you differentiate, you get 2y dy dx because we are differentiating with respect to x, and is equals to 0 because we are differentiating a constant. And collect like terms, that is dy dx on the left side and the constant terms on the right hand side. So dy dx is equals to negative 2x minus 2y, 2x plus 2y. dy dx, you can choose to factor out 2 because 2 is a common term, so this one and this one cancel, and you get negative 2 over 2, which is the same as negative 1. Allow me to change the pen, the color of the pen, to make it simpler. Oh, good. The color of the pen, the highlight to be blue. Let's go on. I want to show you the last example. This one will use it in several situations, like the normal of a curve, the tangent, to find the equations. So example number 4, I hope it is visible. The question asks, find the slope of the tangent and the normal of a curve x squared plus x y minus y squared is equals to 1 at the point 2 and 3. So we are differentiating with respect to x. 2x, you are differentiating the first figure, there is x squared, you get 2x raised to 2 minus 1, and differentiate the next figure, that is use the product rule. Uh, it's from here to here, so you get 1 x raised to 1 minus 1 times y and plus x dy dx, because when you differentiate y you get 1, and minus the next figure is y squared, you differentiate it because it is alone, so 2y 2 minus 1 dy dx. So don't forget to write dy dx is equals to 0 because you are differentiating a constant which is 1. 2 When you simplify you get 2x plus y plus x dy dx minus 2y dy dx is equals to 0. You come and collect the like terms, dy dx to be on the left hand, and the constant figures to be on the right hand side. Because you want to get the gradient which is equals to the dy dx, and because you had initial figures to be 2 3, you come and replace the value of x where there is x and the value of y where there is y, so we get 2 times 2 minus 3 all over 2 all over 2 times 3, we get negative 7 over 2 minus 6, which is 4. We get negative 7 over 4, and negative negative, so negative goes becomes a constant. You get 7 over 4. The equation of a tangent, you come and replace it direct, so y minus 3, which is the 3 is here, and x minus 2 over x minus 2, which is 2 is here, x value is equals to 7 over 4. So I know you still remember the equation y is equals to mx plus c. So you come and cross multiply, you get 4y minus 12 is equals to 7x minus 14. 4 is equals to 7x minus 2. You can choose to simplify inside that, you get y is equals to 7 over 4x minus 2 over 4. You can simplify to get a half or leave it there, it's well and good. And the question was also asking the equation of a normal of a curve. Just to take you through, suppose this is a curve. Suppose this is a curve that is x-axis and y-axis. Sorry, this is the tangent. Bring it closer. This is the tangent of a curve, and the normal of a curve acts perpendicularly to the. This one is normal, and this one is tangent. It acts perpendicular, so you use the equation of a perpendicular, that is m1 m2 is equals to negative 1. So gradient 1 times gradient 2 is equals to negative 1. When we multiply, you get negative 4 over 7. So you come and replace with the same figures. Y minus 3, this 3 all over x minus is the same as negative 4 over 7. So 7y minus 21 plus minus 4x plus 8. You get 7y is equals to negative 4x plus 29. Y is equals to negative 4 over 7x plus 29 over 7. Thank you. Remember to like my page, subscribe for more tutorials. I'm going to take you many examples, and if you have any suggestion you can leave a comment there. Thank you and keep safe.